Alright, continuing with our work on graphing techniques, we have looked at shifting. Now we're going to look at what happens when we multiply a number to our function that we know. So this time we're going to start with square root of x. That should be familiar to us from the last section. And the picture's over here. That should look familiar. And here were the numbers that we talked about. We put in numbers that we can take the square root of, so 0, 1, 4, 9 are good numbers to plug in, and we get 0, 1, 2, 3 for our y values. Okay, so now what happens if we take a function that we know and we multiply by a number out front, so like 2, 3, 4, 5, something like that? Well, we would get something that looks like this. Y is equal to 2 times the square root of x. And what happens is we take our same x values that we have before, and when we plug them in, we're going to do our function to them, and then we're going to multiply by 2. So when we plug in 0, we're going to get 2 times 0 is 0. We plug in 1, we're going to get 2 times 1 is 2. We plug in 4, we're going to get 2 times 2 is 4. And we plug in 9, we're going to get 2 times 3 is 6. So looking at our original chart and our new chart, we kept the x values the same. What happened to the y values? Well, we did our function and we multiplied by 2, so it should be pretty easy to see that our y values here are all multiplying by 2. All of our y values doubled. So let's think about what this would do to a graph. If you think about all of the points on a graph, you take those points and you double the y value. Well, on the top of the graph, it's going to get bigger and bigger and bigger. 0 double 0 is still 0, that's not going to move. And on the bottom half of the graph, when you double negative numbers, they get bigger in the negative direction. So what actually happens is our y values double. That's going to stretch our graph in the y direction. So if you ever played with Silly Putty as a kid or Play-Doh, you can think of it just like that, where you stretch it in the y direction. So let's see what this looks like. We'll do this one in blue. So we get 0, 0. 1, 2, 4, 4, and 9, 6. Alright, so what happens? It stays at 0, 0, but then it's going to stretch up and get bigger and bigger. Okay, so if we multiply by a number, I think that's pretty straightforward to see that we're getting bigger. What happens if we multiply by a number on the inside? Well, I didn't fill out the chart for this one because this one's a little bit different. If we plug in 0, 1, 4, 9, we can do that, but I'm not going to be able to take that square root without a calculator. So I'm going to plug in some different numbers. I'm going to do 0, 1 half, 2, and 9 halves, and hopefully you see why in just a minute. So when we plug in 0, we get 2 times 0, square root of 0 is still 0. When we plug in 1 half, we get 2 times 1 half is 1, square root of 1 is 1. We plug in 2, we get square root of 4 is 2. And we plug in 9 halves, the 2's will cancel, and we get square root of 9 is 3. Alright, so for this one, let's do this one in orange. Okay, so for this one, this is kind of like before. We can see that our y values stayed the same, and I picked these x values for that reason. Our y values stayed the same, but what happened to our x values? In order to get those same y values, our x values had to divide in half. So our x values got chopped in half. So let's think about that on a graph. If you take all of your points and you chop all of your x values in half, that's going to squeeze the graph together. Okay, so like you're taking your Silly Putty and you're squishing it in towards the center with your two hands. So we still have 0, 0. We have 1 half 1. We have 2, 2. And we have 9 halves, which is about 4 1/2, 3. Okay, so this orange one coming up the middle is square root of 2x. Alright, now, on this graph for square root of x, it's a little bit hard to see what's going on between 2 square root of x and square root of 2x, and that's because a lot of times a stretch in one direction looks a lot like a compression in the other direction. If you think about that Silly Putty example, when you squish it together, sometimes it looks like it's pushing the other way. So these are definitely not as distinct as the other transformations. This is something where you would have an idea of what you want, and then you would probably plot a few points, or at least use that idea plus intercepts plus some other things that we're going to talk about. But it's still a good idea to know that when you multiply by a number, you're going to get a stretch or a compression. So we say, let's put that out front first like we did in our example. So if we multiply our function by a number, or if we multiply inside our function by a number, these are a stretch or a compress. So if there are a lot of different cases for these. If a is bigger than 1, then this is going to be a stretch in the y direction. And if a is bigger than 1, this is going to be a compress in the x direction. But you really don't need to go through and memorize all those different scenarios that they have in the book. It's enough to just remember that this is a stretch or compress. Okay, so remember, if you multiply by a number, it's going to be a stretch or a compress. All right, so we've looked at addition, subtraction, multiplication. What else could we possibly throw in here? Well, we haven't talked about what happens if you throw a negative into the mix. So again, we're looking at our original function for this part is going to be the square root function. We've got our table of values that we've seen in our graph over here, so we're familiar with that part. Now we're going to look at what happens if we put a negative out front. So same function, but with a negative out front. Well, I've already filled in the table here. I picked the same exact numbers. Remember your order of operations. So what we do here is we put it in, we take the square root, and then we make it negative. So when we put 0 in, we're going to have 0, square root of 0 is 0, negative 0 is still 0. We put 1 in, square root of 1 is 1, negative 1, we get negative 1. And then same thing here, we get square root of 4 is 2, so we get negative 2, and for 9 we get negative 3. Okay, so looking at our original table to this, we kept the x values the same. What happened to the y values? Well, going from here to here, we can see that our y values all changed sign, which makes sense given that we put a negative out front. Okay, so let's think about this. What happens if we take all of our y values and change their sign? Positive goes to negative, negative goes to positive. All right, well, this should make you think something about symmetry that we talked about before, right? If you change all the signs on the y values, that's going to be a reflection around the x-axis. Remember, x-axis symmetry? So this time we're not talking about symmetry, but we're talking about a reflection. So it takes our original picture and it's going to flip it around the x-axis. So let's draw the points and see what happens. So we've got 0, 0, 1, negative 1, 4, negative 2, and 9, negative 3. And we can see that we have a reflection. I'm off by just a smidge. Okay, so this is negative square root of x. So positive square root of x is the red line, negative square root of x is the green line, and we can see that they are a reflection of each other around the x-axis. Okay, so now let's look at what happens when we put that negative inside of the function. Well, if I put it inside the function, I can't choose the same x values. Remember our domain issue with this, we have to have positive. So what I can put in there is I can put in negative numbers, because negative, negative, that'll come out positive. On this one, we're going to have to do the sign first. Order of operations tells us that. So I can still pick 0, but now I'm going to have to pick negative numbers. So I could do negative 1, negative 4, negative 9. Right? We've got to pick different x values because these x values don't even exist. So when we plug those in, we're going to change the sign and then we're going to take the square root. That's what order of operations tells us here. So when we plug in 0, we're still going to have square root of 0, 0. When we plug in negative 1, we're going to have negative, negative 1. That's going to come out positive 1. Square root of 1 is 1. Here, I can do this down here. Negative, negative 1. So that's going to come out to be positive square root of 1, and that's 1. When we plug in 4, we're going to have negative, negative 4. That's going to come out to positive 4, and that square root is 2. And when we put in 9, negative, negative 9, Square root of 9 is 3. Okay, so on this one, our y values stayed the same, but our x values changed. So how did our x values change? They changed sign. Just like before our y values changed sign, now our x values change sign. Alright, so imagine any graph in your head, any picture at all. What's going to happen if you change the sign on all of the x values? So positive x becomes negative x becomes positive x. If you can picture that in your head, that's going to be a reflection around the y-axis. That should remind you of y-axis symmetry. So again, not symmetry this time, it's a reflection. So when we plot these points, we're going to see we've got, let me do this one in blue. Okay, so we're going to have 0, 0, negative 1, 1, negative 4, 2, and negative 9, 3. And we can see that that is a reflection around the y-axis this time. Okay, so the takeaway here is that when we put a negative in there, we need to remember that we're going to end up with a reflection. Okay, so if we have negative f of x or f of negative x, we need to remember that we're going to get a reflection around x or y. All right, again, the book has a lot of different cases on this. You do not need to go and memorize all those different cases. We'll talk a little bit more about this in class.